Hello guys. So today I'm going to explain you about my thesis topic. My name is Sai Shankar Murli and my ID is X181749990. So my thesis topic is detection of malware in a file using machine learning with the help of KNN model. So let's see what the introduction is. Uh, Day by day in our society and in this world, technology and the latest upgrades have been increasing day by day and they have made very great impact on our day-to-day life. So this makes cybersecurity criminals much more stronger because they have the opportunities to sabotage the technology that by spreading malware like in various forms such as through emails, links, documents, etc. The malwares can be in like any form that can be in a virus, a trojan, a worm, or a botnet. Anything that it can be. So this makes me question: how can we detect malware by using machine learning with the help of KNN model, which we will see in the further video. So literature review. In this section, I gathered many papers by different authors who have who have made these kind of proposals by using machine learning. But also there are many approaches which were made from the perspective to improve the detection or to improve the performance and the method they are going to use, like the different types of models. But the proposed methods, the most of the papers that I have seen in this proposal is that the data sets which were considered to implement in the model, they were not in large in scale, which is a bad thing because uh, the virus and malware can be in any form, in any size. So it is considered as better that if the data is much more and in large in scale, the detection will be much more easier and it will detect the most of the malwares. So let's see what are the process that we are going to use in this machine learning. So the research methodology that we have been used in this is the CRISP DM methodology. As we can see in the side, the image states that there are business understanding, data preparation, modeling, evaluation, and deployment. This means that what are the business understandings, like what are the malware, how the malware can impact on the business side of some organization. They can make a major loss to it. And the data understanding is nothing but you collect the data sets, that you are going to use for the implementation, like malware data set or a goodware data set. And data preparation is if you are going to combine two types of data, or you are going to collect only the certain columns of the data, then you have to do the data preparation. Then the modeling, where you apply the data into the model and it detects the malwares accordingly. Evaluation is nothing but you evaluate the accuracy, how much percent the model has detected the malware. And then the deployment. So the implementation part, for the implementation we have considered different types of model like KNN model, SVM model, support vector machine model, random forest model, and random forest with decision tree model, which didn't give any kind of good results. Random forest performed very well than random forest with decision tree model. But also we have compared all the four models and we have concluded that which one performs better. So the evaluation part. So to evaluate the model that which one performs better, we have used the confusion matrix, which is an inbuilt package in the machine learning system. That is, it shows the accuracy, precision, recall, and the F1 score. Also, the confusion matrix shows us the true positives, true negatives, false positives, and the false negatives, which shows us that how many good files how many malware were detected correctly and how many malware didn't collected correctly. So after all the evaluation part, we have concluded that from the implementation and evaluation, we can conclude that the KNN model, which is the K nearest neighbor model, performs better technique detection and outperforms the other models with the accuracy of 78%. So thank you. And now let's see how our data set looks like. So this is our data set. So in this, we have combined two types of data sets, that is the malware data sets and the binning in applications. So we have used some characteristics like DL characteristics, entropy, image base, size of initialized data and size of uninitialized data. So why have we chosen this kind of columns? That is, so in this we can see that these are the characteristics where the malware can sit in the system, and it can do anything, like it can initialize any kind of data or uninitialized data that are not approved by the user or the administrator of the system. So how have we done this? We took 6 columns from each and we have combined, and we have the future metrics in this process is that we have assumed the malware as ones and the binning in applications as 0. But also our data sets is full of 56,000 combined by the malware and the binning in applications. So let's start how our model looks like, how it performs. So this is the KNN model that has outperformed everything. So first we start with importing NumPy, that are the packages, pandas as the framework, and matplotlib, which helps us to plot the graphs and rest other things like error rate k value. So first we insert the data set where this is the data set, and we can see that the output has been created over here. So now we assign the x and the y, and now as we know that we have what can we say, that we have an imbalance in our data, which is a malware has contained something 39 or 38,000 samples, and binning in files have 26 or 25, something around that. So to balance this data and to get the to achieve the better accuracy, we have used the undersampler method, which somehow balances the data. So to perform this, we have split the data sets into two forms. That is, 70% of the data has been given to the training, and the 30% of the data has been allotted to the test data. Why have we done this? Because if we test the data, if we apply all the data sets to the training data, then there can be some problems that it cannot detect some kind of malware. But in test, we will know, we will get an idea how much it has been detected. So the next step is we have used the sklearn min-max scalar, which performs very good, and it kind of detects everything in the malware data sets. And we have assumed the neighbors, that is 50, which is good because in malware data sets you cannot consider the neighbors values as 3 and 4, because as much as either you set the neighbors as, like, it can be around 200 or anything, it depends on your data. So when we consider 50, then the accuracy achieved was much better than the lesser amount and the greater amount. So you have to change the parameters and check whether it performs good or not. So after applying the k values and everything, we get the confusion matrix. This is the confusion matrix that has been created. So we can see that our accuracy has been achieved 78%, and we can see here that the malware that has been detected is 5764, and the binning in files, that are the goodwares, has been detected 3734. So as we can see that this and this has to be less than the other two options, because that are the true positives. That is the confusion matrix that has been created. So this is the error rate k value. Error rate k value should be greater than anything, like it should be around 200, or it can go till 200. So as much as you increase the error rate k value, that is the k value, it will be decreasing, which is a positive point in this implementation. Also, after we have compared the other data, other models like random forest model, in which we get the accuracy of 51%, which is much lesser than the KNN model. Random forest is nothing but it uses the trees, it uses the nodes to, it goes deep inside to check how much the value is, the tree size and everything accordingly. Also, the SVM model has the second model which can outperform the other two models, like the random forest and the random forest decision tree model, is the SVM model, which has the accuracy of 69%. And the last one is the random forest where decision tree, which has given us the accuracy of 61%, which is less. And also we have identified that there is a imbalance in the data set, as you can see the graph over here. Accordingly we have balanced the data, and after balancing the data, KNN model have given the better accuracy in this. So yeah, this is what my implementation looks like. And due to time constraints, we were not able to extract the opcode and analyze the behavior of each virus or each malware that is in this technological world. So we chose the data sets. My future work will be that to extract the opcodes of as much as viruses possible individually and analyze the behavior, and also to create a real-time malware detection using machine learning techniques. So thank you very much for listening to me.